You're doing the correct operation. What do you have to do for this problem?
Subtract.
Okay, subtract with the key phrase.
Larger.
Okay, how much larger? So you should be subtracting. So Emily and Kaylee. First part. Okay, Emily, do you want to explain how you broke it up, like how you knew to use those two numbers?
Cause in 7, you have to break up 7 to where 5 will like still be in the equation, cause you have to have 5s to like group them together. So you do 5 plus whatever number, and that would be 2, cause 5 plus 2 is 7.
And then where is she now getting 924? Can anybody run into that? Mackenzie.
Because she moved the decimal. Because she moved the decimal because you want to get rid of the.
Okay, so we need to get 2 to the second power into the 9 and 24 hundredths.
Give it 2 places.
So that gave her the 924. So Kaylee's now subtracting. And you should have gotten 920 and 16 hundredths times 10 to the 5th power. But our leading digit, can it be 920? No. Your leading digit needs to be needs to be the 9. So when she brought that 2 to the second power back, sorry, she's having to add times 10 2 to the second power back in. She did move her decimal, which made the exponent increase back to a 7. Any questions there? Okay. I did mention on Friday, because we had forgotten Friday, to check over the lesson 10 problem set. You can quickly get that out. It is on page 45. If you have any questions, please let me know. Number 1, you should have multiplied. What do we do with our exponents when we're multiplying?
No, add them.
You add them together for the multiplication piece. And 3 8/10 times 3 1/10. 1/10 gave 11 and 78 hundredths. But the 11 was too large. So when my leading digit decreased, the exponent increased.
Why would you multiply
Okay, let me present it to you this way. If we run 2 miles every day for 1 year, how do we figure out how many miles we ran in 1 year? Multiply 2 times
Or like
the number of, it's just for 1 year.
You multiply 2 by the number of miles.
2 is the number of miles that we
The
ran.
days of the year.
You would do 2 times the number of days that we ran. So this one was saying that the sun is producing the 3 8/10 times 10 to the 27th power joules of energy every second. We want to know how much energy is produced in a year. So then the problem's giving us that in a year there are approximately 31 million seconds. So then you would multiply what it's doing per second times the number of seconds in the year. Question?
For 3B,
Mhm.
for some reason, I think I rounded, because I put 1.76 times 10 to the 5th power,
That's fine.
and then I got 176,000.
That's fine. And we're pretty close, because like I was getting 175,009. All right, any questions here? Okay, let's do 4 problems on the whiteboard. So really all you need out is your whiteboard, a dry erase marker, and then your pencil. Okay, I do feel like you're most comfortable with the adding and subtracting. Some of you may be comfortable with all. I'm going to go ahead and start with a division problem, but I will review a division, multiplication, and adding, and a subtracting one. Okay, we'll do the stations activity. So let's go ahead and start with 12 times 10 to the 14th power divided by 1.5 times 10 to the 3rd power. Please remember, whenever you're done, just hold up your whiteboard and I'll answer yes or no. Yeah. Remember, based on what we did previously, what you would do with your exponents in a division problem. Yes. Yes. If you need me, let me know. Okay, so this, no, 1.5 times 1.5 can go into 12. How much? Yes. Yeah. You mean switch, yeah. You know, like I'm kind of seeing multiple ways on how to deal with that 12 and that 1.5. Okay, what should your exponent be?
11.
Okay, 10 to the 11th power. Okay, now I'm seeing multiple things for the 12 and the 1.5. Emily actually did this. And based on what you had learned last year, she did this. And then you end up with 24 over 3, which is 8. Okay, I actually saw some actually dividing it out. Okay? Based on what you had learned previously, and 15 goes into 120. 8 times. Okay, and then I even saw some doing 1.5 plus 1.5. Gave you 3 plus another 1.5 until they got to 12. Either way, what should you be getting? 8 times 10 to the 11th power. Okay, so whenever you're dividing, you subtract the exponent and you divide the two numbers, correct?
If you did 1.5 plus 1.5, you got 3.
Mm-hmm.
Couldn't you, because you know that 3 times 4 is 12, so couldn't you just multiply 4 by 2?
You could. That's another way to think of it. Okay, let's try a multiplication one. So let's look at 2 times 10 to the 12th power times 9 times 10 to the 14th power. And again, think of what you learned previously about what to do with exponents when you're multiplying. And now just look at your leading digit. I did 18. Just be careful, I think you just got it incorrectly there. Your process is right, but you have an incorrect exponent. Over 12, 14, give you nice. Yes. Remember to place your next somewhere in here. Yes. Be careful, originally you had an exponent of 26. Yes. Leading digit. Don't break it up. Remember if I gave you 10 to the 12th power times 10 to the 14th power? What would that be? When you multiply powers with the same base. Mhm. Actually multiply them, right. Y'all, the one main thing I think y'all get confused on, you get so used to that rule that whenever you are multiplying, that you add the exponents. Okay, so you should have started with times 10 to the 26th power, and a lot of people start thinking, same question that was just asked, was, do I multiply the numbers or do I add them? Right, anywhere in here is there an addition sign? No, you're only adding the exponents because of the product property that we learned about. Okay? So if you have 10 to the 12th power times 10 to the 14th power, it's going to give us 10 to the 26th power. And then you do end up with 18 because of your 9 times 2. But your decimal is here, your leading digit is too large. Okay, so you should have 1 8/10 times 10 to the 27th power. Okay, let's go ahead and try an addition one. So 1 2/10 times 10 to the 12th power. Plus, let's go with 9 8/10 times 10 to the 13th.
If you need, if you're stuck, you can,
Yes.
no, double check, you need the same exponent before you can add it. So just, you let your 9 8/10 the same. So this part is correct, so you brought it into the first power, what is 9 8/10 times 10 to the first power? 98. Yes. Yes. Yes.
Remember when you're adding, the decimals have to be lined up? Yes. Okay, let's do a subtraction one, we'll check that one, and then we will start the activity. So 2 6/10 times 10 to the 6th power minus 5 8/10 times 10 to the 4th power.
Yeah. I'm just trying to get my exponent to match the 12. So 10 to the. 12th power. 12th power. Times 10 to the first power. Now you getting it? So we broke apart the 13 just so I can start getting my exponent the same. Now I need to bring this 10 to the first power into 9 8/10. So what is 9 8/10 times 10 to the first power? That'd be times 10 to the second power. Mhm. Yes. Yes. Is it a 4 or no? Yes. 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 You remove your exponent to get your exponent of 6. You remove your decimal to get your exponent of 6. And now your exponents are the same, so now you can add your numbers.
Go ahead and clear your desk, all you need is your pencil, because I'll give you the next.
Don't add your exponents. If you add your exponents, you're telling me that something like 1,000 plus 1,000 equals 2 million. So whenever you're adding numbers, do your place value positions stay the same? Like if you're adding 10 plus 20, how many place value positions do you still have? 2. So these numbers will never change when you're adding and subtracting. So I got again, 98 plus 1 and 2 tenths. What's 98 plus 1? Yeah, it does not. So if you have $98 and I give you $1.20, times 10 to the 12th power. Okay, now your leading digit is too large. So when you make it small, what's gonna happen to your exponent? But then something's gonna happen to your exponent.
Okay, we're gonna do another stations activity, very similar to what we've done before. You are gonna be with a partner, there may be one with a group of 3. So, all of the 8 groups, each have a station there, so that's your stations 1 through 8. Again, number 9 on the computer, 10 is on the wall over here, 11 in the front, 12 behind the door, 13 here, 14, 15, and then 16 is on that back desk. Okay? Can you visit a station that someone is already working? No. Okay, so nowhere should I see more than 3 people, because there is one group of 3. If you are visiting station 3 first, make sure you do the work in box 3. Then if you're going to station 12, then make sure you're doing the work in station 12. So you have to complete 10 out of the 16 stations, so it is completely your choice. You are to visit at least 1 ordering in scientific notation, 1 addition, 1 subtraction, 1 multiplication, and 1 division problem within your 10 choices. Okay? So there's different ones spread out throughout the room. To help you with that, on the flip chart, I am saying the only ordering station I have is station 2. So should everybody be visiting that station? Yes. That's the only ordering one. Then I would go maybe pick number 7 for your addition one. Okay? Then go to subtraction one. But on your paper, you need at least 1 from every single type of problem. And then the other 6 are completely really your choice. Okay, so you have choice of which to visit out of these. But then in the end, you also have choice on where to go. Okay, any questions? Paper pusher. Okay, Jesse's gonna come around with these. You can start as soon as you receive your paper. Okay, but remember, with your partner, you may need to go to another station if someone's already working in your group. Yeah. The answers are on the back side of the card, so once again, just like before, you are able to check.
So, 49.
Yes.
Times 5 times 10 negative 50. That's gonna be 3. This is divided. So it would be 3 minus negative 5. So 10 to negative 2. So times negative 2. 49 divided by 5. We would do that. Would we divide those two? Okay. So that would be or 9 to the 8. So 5 goes into 45 9 times. Then 4 out of 5, which would equal to 8 out of 10.
Remember to check your answer.
Times 10 to the negative 2. Oh, what? I want to add these and it makes it positive. That's what we messed up.
Okay, so thinking if you're trying to find an average, so let's say
But then I put We could, we did, negative 6 6.
Because that's an
The zero is
-3 minus -5.
Did you like put the decimal point?
No, it should be 9-1. You only have to move it once. And it should have been right here.
Well, that's why it's negative.
No, no, it's because whenever, you can't have it more than 10, you only have to have it less than 10. Less than 10, 1 to do. That's what I do. No, but you have to start it with. So we both do, then you gotta do it. You have to, you know what, you have to start with the number, find how much you want to do. When you're multiplying, you do my 41, because that's we can go to the, that one just try to just read the
They don't know whatever station it is.
So be 10 to the 6.
Our LVM.
You don't put the decimal point. And what's your exponent right now? First power.
It's a negative 6, right?
Add the numbers and then put it in.
Did you get it? Alright, let's do it.
Right. So you have to get like 2. And then
So we just have to split up the exponent.
So,
Well, whenever you're adding.
true, because it's least. The 2 is great. The 2 is less than 7. Yeah, now it would split up the next
You need 10 to the second power because you also have 10 to the 7.
yeah.
So then you do 4.5 times 10 to the second power. That's 450 times 10 to the 7th power. Minus 5.7 times 10 to the 7th power. Can you subtract 450 5.7? Yeah. So this is going to be 60. I was just minus 10 to the negative 3. Alright, 9.9 times 10 to the negative 3. Same thing as the first one. Then 6,000 times 10 to the negative 3. Alright, so now 2,000.
You know, like I just want to.
Maybe 54. Then mine would give it 54,000.
Okay, and then what was your thinking about this?
Either way, the first digit is 54,000. I know that for sure. 9, because the 9 would make it. Well, I have a calculator.
Well, don't, now, what do we say to do with the exponents? And so then what do you do with the two numbers?
What do we do?
So on a multiplication problem, y'all told me earlier what do you do with your exponents? You add them. And then what would you do with the 9 and 9/10 and the 6?
You would multiply.
Multiply them. I think y'all had started to try to get the exponents the same, but you don't have to on a multiplication problem, because you just add your exponents together.
So 59.4. Well, I mean minus 5.7 times 10 to the 7. Yeah, and then it's minus 5.7 times 10 to the 7.
This one closer to this positive answer?
Because it's...
You would still compare your numbers. Because these are negative numbers. The negative exponent is representing really small numbers.
Yeah, 6.2.
This stuff, because you don't see the times.
So this is addition 1.
Okay, so now it's there with 100 down and you're 20 registered. 120 registered.
I'm trying to get these the same. We broke this down into 10 to the second and then to make it
Hey guys, listen up really quick. Tonight, I need you to listen carefully, please. Tonight, you are going to complete the stations activity for homework. So I did make copies because your test is when? Tomorrow. Okay, just reviewing one last time. When you are multiplying numbers in scientific notation, someone raise your hand and tell me what to do.
Multiplying numbers?
When you're multiplying them,
the exponent.
you add the exponents, and then what do you do with the numbers?
You multiply them.
Multiply. When you are dividing numbers in scientific notation, subtract the exponents, and then divide the numbers. When you're adding and subtracting,
You have to break down
If they're not equal.
if the exponents are not equal, you have to break down the larger exponent. Okay, any questions? Okay, I will be collecting this tomorrow, so please make sure you use it as a study guide tonight. Whenever you get back to your seats, I'll pass out the paper that has all the stations on it.